So this is a podcast, a recording. And my topic is what I want to touch on is the concept of dark energy, dark matter, what this means for astrology and human consciousness. So it's going to be a very rapid podcast. I don't intend to spend so much time on this. You know, dark energy and dark matter are concepts that have been intuited as explanations, or they have been inferred as explanations for some of the anomalies discovered using 20th century physics, relativity and Newtonian physics, basically classical physics. And the reason being because certain laws of physics appear to be disobeyed when large-scale phenomena like the universe or spiral galaxies are observed. The dark matter was intuited. One of the inferences for dark matter is the anomalies when it comes to the rotation curves of spiral galaxies. The stars on the outer rims appear to be moving much faster than predicted, and at that speed they should be flying off the galaxy based on the conservation of angular momentum. One other inference is gravitational lensing. I mean, you can see clearly smeared out images. You can clearly see that there is something acting as a distortion field, distorting light from that object and bending it just the same way you would expect if you had a curvature of that space, and yet there's nothing there. There's nothing there that you can see causing the distortion. So there's something that's invisible, cannot be seen, and yet it's distorting. It's powerful enough or heavy enough or dense enough to bend light from that object. So those are, there are several other inferences used to infer the existence of dark matter, but I'm just going to stop at this too. Now, for dark energy, the inference comes from the supposed expansion of the universe, and it's really simple. Ever since Hubble measured the universe, he found that we live in an expanding universe. I mean, Einstein expected the universe to be stationary, which is why he introduced his cosmological constant in his equation to try to steady out the universe and balance it. But when Hubble discovered that the universe was expanding, Einstein called this cosmological constant his biggest blunder, because it was like a forge factor. But even that forge factor turned out to be brilliant, in the sense that when the universe is expanding, then what is that expansion? What is what is the field that is expanding? Basically, it is the cosmological constant. And so, even Einstein's mistakes, well, turn out to be brilliant. Anyway, and what that did was, but the expansion is not uniform. It's found out that the further back you look, the expansion rate is changing. It appears that the universe is expanding faster and faster. And it's been inferred that for the universe to be expanding, for the entire universe to be expanding, there's no central point for the expansion. The expansion is occurring everywhere. And so it's a metric expansion, it's a scale expansion. So for this to be happening, and that means that there is an energy that is capable of doing this, and that energy must counteract the overall energy of all the gravitational matter in the universe. And it's a kind of repulsive force pushing everything apart. And and this energy was called dark energy. And it's one explanation for it was given from quantum field theory, as in the instantaneous appearance and disappearance of virtual particles, as based on the uncertainty principle. But when some rudimentary mathematics was done on this and tried to calculate the amount of energy created virtually in space, by so-called empty space, the energy was 120 orders of magnitude greater than what is observed. So that is clearly shows that there's something wrong there. This energy just popping out of empty space through virtual particles is not really a credible explanation. Now, in this talk, I want to offer a different perspective, and it is a perspective that is coming from my work. Now, my work is based on what I have called the principles of organized complexity. And organized complexity is really simple. Why is there order in the universe? That's the central question, is where does the organized complexity of the universe, where does it come from? Okay, and that's another way of asking where we come from, because life, for instance, is a feature of organized complexity. You see, I mean, so these are deep questions. Now, and in my and within the 5 principles which I created, I gave the example I used. I consider to be the most minimal representation of organized complexity, which is the distribution of prime numbers. So for that, I went into detail of how the prime numbers are arranged within the natural number system. I described the natural number system not as a one-dimensional system, as is often thought when we're kids, but as a 3-dimensional system. And I said that the reason why the world appears 3-dimensional is because the organization encoded within the distribution of prime numbers is 3-dimensional. Now, and I described time as a rate of change that occurs within this 3-dimensional space. So time is a property of the 3-dimensional space. If you want to give, just like Einstein did, if you want to assume that time is a separate dimension, you can do so. But the most important thing is that it is a 3-dimensional, from the point of view of reality and nature, there is no time. Everything that exists simultaneously, past, present, future. So time is a feature of the dynamics that takes place within this particular model that I created. And it is from there that I was able to derive some of the quantum properties of those models. So in my model, essentially, is a model that you can use to reconcile quantum theory and relativity theory, because the momentum transfers that occur in relativity theory and the quantum oscillations that describe a quantum theory or even quantum field theory, they are all features of this model. And from there, I argued that the reality, existence itself, is built from this model. It emerges from this model. And I basically concluded that because the distribution of prime numbers is the densest set within this model, and that distribution is built around the 3-dimensional structure of the number 6, then what I'm basically saying is that if this model is a model of reality, then it must be able to explain the existence of dark energy and dark matter. Now, this model in itself is, once I draw it, or if you look through my ebook, it's you can represent it as a plane, in a plane, okay, on a 2-dimensional plane, basically. And you can clearly see that and if that model represents the structure of the universe, then that is the emergence of the universe. The 0 point of that model would be the original singularity of the Big Bang. So from that singularity emerge an infinite number of trajectories. But there's a relationship between those trajectories, because that relationship must be maintained because of their origin in terms of the distribution of the set of natural numbers, the way they are represented 3-dimensionally. Even though there's an infinite number of trajectories emerging from the Big Bang, there's a structure to those trajectories, and it's that structure that carries the distribution of prime numbers. Now, from the way I described it, when you look at a spiral galaxy, for instance, okay, because these infinite trajectories that emerge from my model, from the singularity point, from the 0 point, they're spirals. The entire diagram itself, the entire model itself is a spiral. It's just that instead of emerging in a logarithmic space, they have emerged in a flat 2-dimensional space. So you see them as straight lines. But in a logarithmic space, they're spirals, okay? Because they have the behavior is because in this model arithmetic and multiplication meet. So, and that's how logarithms are basically imagined. And so the space is a natural and faithful representation of a logarithmic space. It's just that it's represented as straight line. The representation is the scale is 1 to 1. So you see them as straight lines. So when you look into the